So, hello everyone. Thank you for having me at IGBO. I'm very excited to be here. Today, I would like to talk to you about a study that I've done in collaboration with Martin Schevland at the University of Oslo. And I'll be talking to you about concrete names for complex expressions and ontologies. So let's just jump right into it and let me explain to you what I mean by that. So yesterday, I think, we have listened to Barry Smith mentioning some OBO principles by which ontologies in the OBO foundry or the OBO libraries are supposed to be constructed by. One of these principles says that classes in ontologies should have a textual definition that essentially explain what a term that corresponds to a class means. And there's also a recommendation that says, well, there should be a close correspondence between the textual definition on the one hand and the logical definition on the other hand. And that got me wondering whether this is actually what people do. So do people provide textual definitions for all classes? And then do these textual definitions correspond to logical definitions? So here's just an example of how this might look like. And I don't care too much about what this liquid state actually is. All I care about is whether this textual definition corresponds to a logical definition. And as you can see, I've indicated this here with a color scheme. It is possible to have a textual definition that closely corresponds to a logical definition. So this is awesome. Now, you could, of course, check whether this is true for all textual definitions in an ontology, but I didn't want to go there. What I was interested in first was whether such logical definitions are reused consistently throughout an ontology. Now, what do I mean by this? Here, we have two concepts, two named things, clotting and liquid state, and they are defined. The meaning of these terms are defined with logical expressions. And what we can now see is that the way this liquid state term is logically defined reoccurs in the definition of another term, namely clotting. And this is a bit odd because I was thinking, well, if we have a named term for a logical expression, why don't we reuse this named term? So we could, of course, define this term clotting in the terms of other terms that we have already specified, right? And I would make the argument that this definition is smaller, hence more readable, and probably also easier to maintain because, well, if we reuse terms consistently and we need to change them later on in the future for some reason, then we only need to touch the definition of the term itself and not touch all the other definitions that might depend on this term, right? And by the way, this is not a made-up example. I've taken this example from a publication from Nikitina and Koopman in the year 2017, and it's a great paper, and I highly recommend you have a look. Anyway, back to the topic at hand. So I was wondering how these named classes, which have a definition, a logical definition, are used in ontologies. And this raises then the following research questions. Number one, how many concrete names do we actually have in our ontologies? How often are such names reused? And how often are such names not reused despite being available? And when you ask these kinds of questions, you of course have to, define your notions with respect to which you want to measure these things, right? So let's just do this. I apologize, this is going to be a bit dry, but it's important so that, we all know what we're talking about here. So I define two things. I define abbreviations and synonyms. Let's start with an abbreviation. I say that an abbreviation is a named class in OWL that is equivalent to a complex class expression, right? And this is just that in OWL, and a synonym is a named class that is equivalent to another named class because you could use them interchangeably, at least on the level of OWL, because they're logically equivalent. And I call these things simple definition because they own the axiom that corresponds to this definition only consists of these two arguments, the named class and the complex class expression. But now it's important to remember that the OWL constructor equivalent classes takes more arguments than just two. So we could also specify definitions in this way, where we say we have a named class that is equivalent to multiple different complex class expressions. And in this case, you would not necessarily know which complex class the named class refers to, but you know that they are all equivalent. And in this case, I would call these things ambiguous. So we have an ambiguous definition for the term that represents this named class N, and the same for synonyms, of course. And then the last syntactic variant that we have would be a compound definition where we specify multiple different named classes to be equivalent to multiple different complex class expressions. Now, I'm not sure how important this is in practice. The only reason I'm bringing this up is because it's syntactically possible to use the constructors in this way, all right? And in practice, it turns out that most people use simple definitions, even though there are some caveats to it. But in the remainder of this talk, I'll only be talking about simple definitions. All right, next up. Since we talk about our ontologies, we have the distinction between things that we state, and I call these things explicit definitions, and things that we can infer even though they are not stated, right? So now we have a notion of an implicit definition for a named entity. All right, so what we can then do is, given an ontology and given a set of implicitly and explicitly defined definitions of these named classes that are equivalent to complex class expressions, we can ask whether these named classes are somehow used in the ontology or whether the complex class expressions occur. And I refer to these things as either the use of this named class or as the possible use of a named class if the complex class expression occurs. Because remember, these things are logically equivalent, which means if I have a complex class expression, I could instead reuse the named class because, again, they are logically equivalent. Okay, great. With all these notions, we can now run some experiments and actually check what people do in their ontologies in the real world. So let's do that. Let's just look at the number of syntactic definitions in ontologies. And what I found here is that, all right, so first I need to tell you where I get my ontologies from, of course. I went online and I just downloaded all ontologies that are indexed in Bioportal. And I included all ontologies in my experimental corpus that I could process with the OWL API. And this then resulted in 744 ontologies that I could run my experiments on. And what I found then is that in 41% of these ontologies, we have these abbreviations, meaning we have logical definitions for named classes. And synonyms also occur, but to a much lesser degree, only about 18%. And another important characteristic to look at would be, okay, given an ontology, how many definitions do we have in an ontology? And that depends a bit on the size of an ontology, but I would like to emphasize that we find some ontologies, some large ontologies, where we have a large amount of definitions. So what this tells us essentially is that these abbreviations, these definitions are important in many ontologies. And that's the first thing that I would like you to take away. Now that we know that we have many definitions for these named things, we can now ask whether they are also used. And here I found that in about 80% of ontologies that define such named terms, they are also used. And here I emphasize that all of them are used. So whenever you introduce a term, then this is a term that you use to define other terms. And I find that this is just super interesting because it seems to suggest that people who create ontologies build up a vocabulary of interdependent terms. Right, the next question then is, how often are these defined things reused? And again, that depends on the ontology, but some named terms are reused quite often. And again, if I were to summarize this, I would say that many abbreviations are used and some abbreviations are quite important in an ontology and are used frequently. All right, and this brings me to my last question, which is the possible use. So just as a reminder, a possible use is an occurrence of a complex class expression that is equivalent to a named class, meaning we could replace the complex class expression with a named class in the ontology. And here I found that in about 33% of ontologies that explicitly define abbreviations, there are some possible uses. And this is quite interesting because the other 66% of ontologies do not give rise to possible uses. So that seems to suggest that defined classes are in fact reused whenever they can be reused, right? And now the next interesting thing is looking at implicitly defined abbreviations, meaning now we have a named class that we can infer to be equivalent to a complex class expression, but this definition is not explicitly stated. And in these cases, I found possible uses for pretty much all the implicitly defined names. So this then raises, of course, the question whether we would like to make these definitions explicit and then also reuse them consistently. And right, in the case of these implicitly defined abbreviations, I also found that sometimes these implicitly defined abbreviations give rise to many possible uses, meaning there are many instances of these complex class expressions that reoccur in an ontology that you, if you wanted to, could replace with a named class. Right, so summarizing that, abbreviations with many possible uses exist. And this now leads me to my conclusions, which is, well, we know that logical definitions are important. We know that people use these logical definitions, but we also found that there are instances of possible uses that seem to be quite large in number. And at this point, this is just a phenomenological study. So I'm just presenting you some findings that, you know, are prevalent in our ontologies. I don't know yet whether I would want to propose the reuse of these named classes throughout an ontology whenever possible. So this is what I'm a bit cautious about. I would just like to ask the community that is present here whether equivalent named classes should be reused whenever they can be reused, whether we should introduce named classes for reoccurring complex class expressions, and whether non-ambiguous definitions should be avoided or not. I've already talked to a bunch of ontology developers, and there doesn't really seem to be a consensus. There might be a general tendency of how these things should be used, but there are always exceptions and caveats that are worth discussing and taking into account. So I would really like to get to the bottom of this and ask when and why would we like to reuse named classes? When and why should they be introduced? And when and why should non-ambiguous things avoided? Or when is it okay to reuse ambiguous definitions, for example? And like I was saying, I don't have the answers to all these questions just yet, but I would like to provide tooling and support to deal with these sorts of issues. So if you have any kinds of ideas or suggestions, reach out to me, let me know, and I'm always happy to chat. All right, so now I think I still have a bit of time left, and I would just want to mention a few directions for future research, because all of what I've presented so far could be said to be somewhat simple and straightforward, right? So we have a logical definition of a named class that is logically equivalent to a complex class expression, and I'm just asking, okay, are these things reused consistently? That almost looks trivial, but if you actually look into practical issues, it's not quite as trivial. But it can get quite intricate and complicated real fast. And I'd just like to show you how this could come about. So this is just, these are just some directions for future work. So the first question one could ask is whether named things should be exhaustively reused throughout an ontology. Now, what do I mean by that? Let's just look at the logical definition of the term clotting again. So we can see that there's a bit of nesting of logical constructors going on here. And what we could now do is we could define multiple different intermediate terms and could give them names, right? And then we could do this replacement of the complex class expressions with named entities iteratively, right? So let's just do that. So we have the concept clotting that we define in terms of this large complex expression. And we see that we can replace the physical state with the liquid state here. And if we do that, this then gives rise to another potential use of this expression liquid blood. And we can do that too. And suddenly the definition of clotting becomes quite neat, I would say. And in this case, this worked out quite nicely because it's it's an example in a scientific presentation, but in practice, this iterative replacement can get quite tricky. So you don't necessarily know which replacement you should do first and whatnot. So here you can quickly ask the question, okay, what replacement strategy should I use? Does the outcome matter? So do I want to make sure that the replacement leads to some kind of size minimal rewriting of my ontology? And once you go down that path, you can already define this problem in terms of a computational problem and then ask questions about the computational complexity. And I hope that I have convinced you that this gets tricky real fast. I've already done some preliminary work on that and I have some results, but that might be the topic of another talk. All right, so this is one direction in which this work could be extended, which gets tricky real fast. And the next interesting topic is whether you actually want to introduce named entities into your ontology. And again, it's not as straightforward as one might think. So let's just look at an example here. So we have 3 axioms, and you can see that so these axioms are taken from the pizza ontology. And the expression of a pizza that has the origin of Italy occurs twice. So you could say, since this expression occurs twice, how about we name this and we make the this expression equivalent to the named class Italian pizza, and that would then allow us to replace these complex expressions with this named class. But if we do that, we essentially change the meaning of our ontology, because we've now introduced a new named entity into our ontology, and that also affects the class hierarchy that we're constructing, right? And this may be a big deal for practical applications. So if I do this for, let's say, lots of different complex class expressions, I can possibly blow up my class hierarchy to a degree that people may not want to look at that class hierarchy anymore. So it's, it's a bit tricky to find some good principles or rules for when you want to introduce a named class into your ontology and when not. But interestingly enough, there's also another way around this problem. So we could think of some kind of macro system where we just say, okay, we know that we want to introduce a name for this complex class expression, but we don't want this name to represent a named class. So what we could do instead is we could just say, well, let's define a macro system similar to the macro system that we have in programming languages for C, for example, where we say this is just syntactic sugar. So whenever I define this macro for Italian pizza, that is indistinguishable on the level of owl from this complex class expression. So what this means is that if you take this ontology that has this macro symbol in it, and you would want to classify it, then you would first have to expand all these macros so that you only get your owl expressions again. And in that case, this would correspond to the original ontology that we started with, right? Meaning the inferred class hierarchy of this ontology O and the ontology OT would be the same, because this name that I introduced here is just a macro. It doesn't really correspond to anything on the level of owl. Well, and once you do that, you can, of course, play this game a bit further and ask, well, maybe we also want to have a more powerful macro system that allows for some notion of abstraction. So here we can see, for example, that the complex class expression for the country of an origin of a pizza has both Italy and Canada as possible values, and we could just abstract over these differences. And I've done that here with the introduction of a variable, right? So now I could say this is a macro with an argument, so that's a parameter that I can instantiate. And in this case, I could just rewrite my original ontology with this parameterized macro. And this just gives you a way of essentially rewriting your ontology in a more intention-revealing manner. And here, I would like to come back to the work of Martin Chevland, which is all about reasonable ontology design templates, which essentially allows you to do this. And I think it's a great line of work. And if you'd have the time to check out what Martin does, please do. I think it's a great tool. All right, that's all from me now. I would like to come back to my questions that I asked and would hope that some of you have some useful feedback for me. Thank you so much.